Yes, good evening, everyone. I am Mie. Today we have four speakers slash engineers, Lucille, Sikian, Carmen, and myself, Mie. So to begin with, I would like to ask all of you a question. So what is your opinion on the current percentage of harassing comments on X, also known as Twitter? Please type it or say if you have a number in mind. Oh, okay, 10%, 30%, 20%, 40%. That, yeah, those are really 80%. So, yeah, in fact, about 3 to 11% of the posts on X, also known as Twitter, are harassing. And so according to research in the US, about 37% have experienced online harassment. This is a student, middle and high school students in the US. So that's a pretty high number. And I'm pretty sure everyone has experienced or seen harassing contents on social media. So this really shows that we need to find a way to filter out harmful content. So what is Emakia project? Emakia is a nonprofit startup focused on researching and developing technology to filter out harassment or unwanted contents for social media users. And we particularly focus on marginalized communities such as women, people of color, LGBTQI plus individual, and others. On the bottom right side, her name is Corinne David. She is CEO, CTO, and founder of Emakia. So by the end of this presentation, you will learn about model training, with Vertex AI. Vertex AI is Google Cloud Platform model, and also Python and JavaScript. So this part is talked by Carmen, and Lucille talks about data code management, validation, and collaboration. And she will briefly discuss about text classifier and sentiment analysis. At the end, Sikin talks about data visualization. And after that, I will quickly mention future direction of Emakia project. So now let's turn our attention to our next presenter, Carmen. She will be discussing model training.
Thank you, Mia. Hi, everybody. I'm Carmen, and for the first portion of this presentation, I would like to talk about how we work with our data using an online prediction, batch prediction, Python, and JavaScript. We had the opportunity to be financed by Google, so in turn, we got the opportunity to use Vertex AI on Google Cloud Platform. So first, we started off our project by training a model using Vertex AI. Training a model on Google Cloud Platform involves using Google Cloud Platform's infrastructure and services to teach a machine learning model to make predictions or decisions based on data. It's like showing a computer a bunch of examples so it can learn patterns and relationships, allowing it to perform tasks without explicit programming. So specifically, we trained an auto machine learning text classification model where we included 130,000 training text data sets and 70,000 testing text data sets, and resulted in making a precise prediction of 93.7% on static data, where we got the data from a university research team. The difference between model training on Google Cloud Platform consoles versus using an API is that the GCP console is a graphical interface where you can visually set up and control tasks without writing code. And you navigate through forms and options, making it easy to understand and monitor the training process. As for using an API, it involves writing scripts or code to interact with GCP services, giving you more control and flexibility, and which allows for reproducible and customizable training models. Overall, using an API is more suitable for advanced users. So what is the difference between online and batch prediction? Well, making an online prediction is like getting instant information as things happen, like using a live chat. It helps us make quick decisions by analyzing data in real time. For example, online prediction on Google Cloud Platform is like having a smart assistant in the cloud. You train this assistant to recognize patterns or predictions, and once it's ready, you deploy it to the cloud. Now, whenever you have a new question, which in this case is data, you just ask your assistant and it gives you an answer instantly, making it great for applications that need quick and on the spot insights. Whereas completing a batch prediction is processing a bunch of data all at once, like taking a portion of a stack of papers at a time and feeding it into a sorting machine. And the machine processes all the papers in that batch simultaneously, making decisions for each document collectively. Batch predictions help us see big patterns and trends, which helps us get predictions for a lot of things all at once. The way we implemented an online prediction within our project was by deploying our model, creating an endpoint, preparing new data, sending prediction requests, receiving the predictions, and then interpreting the results from there. The way we implemented a batch prediction was by preparing our model, organizing our data, uploading our data into a cloud storage, creating a batch prediction job, monitoring the job process, and then retrieving the batch prediction. And at the end, we ended up using a batch prediction to construct our table. In the future, we would use an online prediction for production. Also within our project, we use Python for proof of concept, and we use JavaScript, but more particularly Node.js for production. And now I'll hand it off to Lucille to discuss the next part of our presentation.
Thank you, Carmen. Hello, everyone. I'm Lucille, and today I'm thrilled to share our experience with BigQuery, data management, open source collaboration, and a glimpse into different types of validation. With BigQuery, you can manage and analyze your data. This is the schema we used. So you can see the text is the tweet. Twitter prediction. If it's considered harassing on Twitter, it's marked as true. If it's not, it's false. And for display name, we follow a similar pattern with 0 indicating non-harassing and 1 indicating harassing. BigQuery is a powerful tool for handling vast datasets. We've built a table with over 130,000 rows of data. Managing such large data posed its challenges. For example, we had to enhance our code by processing it in batches for safe and efficient scaling. And we ensured our code performed well and structured the table appropriately. To evaluate our text classifier model with real-time data, we would create matrices such as confusion matrix, recall, and precision matrix. And to do that, we need to evaluate if the prediction is correct or not. To evaluate our model's predictions, we can use Twitter-sensitive predictions that you saw in our schema earlier, but also lexicons or sentiment analysis. A lexicon is essentially a dictionary or a set of words. Utilizing lexicons in our validation process involves cross-referencing the harassment words in the tweets. By incorporating lexicons alongside other tools like Twitter-sensitive predictions and sentiment analysis, we enhance the accuracy and depth of our model's predictions. Sentiment analysis is a Google Cloud API, and with sentiment analysis, we can try to understand people's sentiments in their tweets. So we looked at the emotions in a text, and this process can also allow us to evaluate our text classifier model. I would also like to share that we use GitHub to work together and set up the project for open source collaboration. In the future, we would love to engage with communities like Women Who Code and present our insights on platforms such as Kaggle and help grow our knowledge all together. So our journey with BigQuery, data validation, and open source tools was challenging and exciting, and we learned a lot. We're excited about what's next. And now I will pass the floor to Sikyang, who will present our data visualization.
Thank you, Lucille, and hi everyone. My name is Sikyang again, and I will share with you our results. And I'm using Looker Studio in Google Cloud to work on this report. Next. So this is the report of harassment variation depending on the thresholds. The thresholds here means our confidence levels that we set during our prediction using Google Vertex AI. And if you see the graph on the left, shows that there is 0.8% of the total tweets are harassing based on X, formerly Twitter, prediction model. And if you look on the table on the right, it is the result of our model prediction with 5 different thresholds from 50% to 90%. And setting the threshold high lets more potentially harassing content go through. And if we set it too low, it's block more of that content of harassing. So if you see the first row with the 50% confidential level, our model can predict 4,147 tweets are harassing. And with that, we have 3% ratio harassing compared to the total tweets. And for the last row with the 90% of confidentiality, our model could predict only 200 tweets are harassing. And with that, we have like 0% ratio harassing compared to the total tweets. Next. And this is the tweet prediction analysis from our work. If you see the table on the left, it shows that both model here means X, and our model could predict 15 tweets are harassing. And the table on the right show that our model could predict 1,130 tweets are harassing, while X couldn't predict at all. Next. And these results show that on the left table, both models predict that there are 135 and 660 tweets are neutral. It means like the content are not harassing. While the table on the right shows that our model count 1,145 tweets are neutral, and X predict that they are harassing. And with that, let's move to Mie to wrap up our presentation. Back to you, Mie.
Sure. So in summary, Carmen talked about model training with Vertex AI and Python for proof of concept and JavaScript for production. And Lucille talked about data code management, validation, and collaboration on GitHub. So we are planning to open source our project so that anyone can grab it in the future. And briefly talking about text classifier and sentiment analysis. Sikyang talked about visualization on the Looker Studio on Google Cloud. So how can we extend from here? Brainstorming future directions. Because we currently mainly focus on text on social media, and it is possible to use LLM, large language model, to do sentiment analysis and text classification for Emakia project as well. For example, GPT and Gemini and many other large language models is suitable for this. And social media, in fact, involves not only text but also images and videos. And images and videos can contain harassing content as well. So filtering images and video can be done using a large language model as well. Recently, Gemini and GPT-4 is released, and there are many other multimodal LLMs out there. So it is possible to expand our project potentially in the future to include these new kind of machine learning models as well. So thank you all for your time and attention today. So if you have any further questions or would like to discuss Emakia and how we built in more detail, we'll be in a separate breakout room for Emakia. Or if you are interested in networking with us, please feel free to reach out to us after the presentation.
Wonderful. Thank you so much, Mie, Lucille, Carmen, and C. King. Thank you so much. And I'll go ahead and stop the recording now.